For today's video, we're going to talk about velocity. And velocity is a perfect spot where we can use vectors because velocity is talking about the speed and direction. Often we're just interested in the speed of something. But here, for these questions, we're interested in not just the speed, but also the direction in which that speed is going. And the example we're going to talk about is flying a plane. So flying a plane is a little bit different than, let's say, driving a car on the 401. When you drive the car on the 401, you just pretty much put it in the direction you go and you travel in that same direction. There are lots of other factors on how fast you're going and things like that, and wind does kind of play into effect, but wind doesn't blow a car off the 401. Okay, there's friction on there to hold the car in place, but that's not the same for a plane. A plane doesn't have the luxury of tires holding it down, and it's at mercy of the wind. And so when, even though the pilot may be pointing its plane in a certain direction, the wind will actually blow it a little bit off track. And so the pilot needs to account for this. And so that's where these two vectors will come in. So we've simplified the question down to a vector that represents what the plane wants to do, and then we've got a vector that is what the wind is, and the result is what the plane actually does. So this is very important for pilots because they need to account for the wind. If they're aiming in a certain direction and they don't count for the wind, they're going to be flying off track. So in some questions, we need to know where to aim so that the wind blows it on track. But this question is going to be a simpler version of that, where we're just going to find out what the plane is doing, because we'll know what its steering is, and then what the plane or what the wind is doing, and we'll find out what is called the ground speed. Okay, so the ground speed is a combination of the airspeed plus the wind. So we have to take into account what's going on in these two scenarios. So the airspeed is what we have in this question, what the plane is actually doing up in the air and what it wants to be doing up in the air. And then we add the wind into this scenario to find out what it actually would be doing if you were looking at it from the ground. So it's called the ground speed because that's what you see. If you look up above you and see a plane, you're actually seeing a result of what the plane is steering and the wind, and you're seeing the ground speed. Okay? So in these scenarios, we're going to think of that, but instead of looking from above, I'm going to imagine we're looking at the scenario, or sorry, instead of looking up at it, I'm going to imagine we're above the scenario and we're looking down at these two vectors and seeing the result of the airspeed plus the wind. Okay? So we're going to call these vectors the g vector for ground speed, and we're going to say it's an addition of airspeed plus wind. Okay? But before we get to that, we have to imagine what these two vectors look like. And what I suggest you do is off to the side, you might want to start drawing these vectors on their own before you try and actually draw this addition of the vectors. So I'm going to do that by starting by grabbing an arrow here, and I'm going to try and draw this plane. So the plane is steering north 40 degrees east at an airspeed of 500 kilometers an hour. So if I'm going north 40 degrees east, that means I point my vector first to the north, and then I go 40 degrees in the direction of east. So this, of course, would be northwest, and this is northeast. Okay, so north 40 degrees east. So we have to just estimate this. We're not going to have a perfect picture here, and that's okay. But there's 0 degrees, so this would be 90. Halfway is 45, so I would say 40 degrees is maybe something like that. Okay, and that's a little estimate. Now, to help me with this vector, I'm going to encourage you to draw these little things. So these are little crosshairs, I call them. They're like little compasses to help you imagine or actually see the direction that we're talking about. So if I was to draw this, I would say that this is your 40-degree vector. Okay, so I'm just going to make that blue. And since we're talking north 40 degrees east, there's your imaginary north side that's not actually a vector, it's just your imaginary north, and you know you go 40 degrees east. Now, when I've drawn it there, I feel like it should be a little bit more like that. Okay? Now, don't stress about your accuracy. I think that's pretty good. It's just an estimate. All right, so I've got that guy here, and I'm just going to leave it there for a second. And now I'm going to talk about the wind. So wind is given a little bit different. It says it's from the northwest. So if you hear about wind and if it's going nautical miles and all that sort of stuff, and you hear there's these wind reports on the radio about for sailors, everything is given in the direction that the wind is coming from. It's not telling you where it's blowing, it's the direction that it's coming from. So this is from northwest. So if it is from the northwest, that means it is blowing southeast. Okay? So if we see that it's from the northwest, we are actually blowing southeast. Okay? So that's really important. It's not true for these things. These are just given to you in the direction they're actually going. But wind is given to you from where it's blowing from, and we need to change that into the direction it's actually blowing. So if I was going to go draw my vector for this, if I was saying northwest, that's where it's blowing from. So it's blowing in the exact opposite, and it's southeast. Okay, so to draw this, I'm going to go directly south, and I'm going to go 30 degrees to the east, which, that would be 45. Let's say that's about 30. Now, you'll notice my vector isn't as long because this one's only blowing 85 kilometers an hour, and this vector was 500. Okay, so this vector should be about more than 5 times bigger. But don't stress about that. Sometimes you'll get really, really big vectors and small vectors, and it's hard to draw the picture. But we've got the idea of the picture that's going there. So I'm going to pull out another one of these guys, and I'll just copy this and say then that this little angle in here is 30 degrees. Okay, right in there. Now, you notice I've done these separately because I didn't want to try and draw it right on the picture. By drawing it separately, I've got a really good idea of what the picture is doing. And so now I'm going to do this math where I'm going to say the ground speed is going to be a result of the air speed, which is this guy, plus the wind. So I'm just going to take this and add it on to the end of that vector, airspeed plus wind, and we get that result. So the result is a new vector, which I'm going to make red, that goes from here right to there. And that is the ground speed. That's my ground speed. Okay? And it is the result of the airspeed plus the wind. Now, if you look in this particular example, you'll probably notice that this red vector is slightly smaller than the blue vector. So if I had to predict this blue vector is 500, I'm going to predict that the ground speed is a little bit slower. And the reason is it looks like that the plane is actually traveling into the wind. So the wind is pushing against it a little bit, but not completely against it. So it's not like we can just take 500 minus 85 to get the result. It's pushing it off to the side, but it is influencing it a little bit. So I'm going to guess that this red vector is going to be slightly smaller. That's not always the case. Maybe the wind's blowing with you, and it actually goes bigger. And this happens in all realities. Sometimes your speed of the airplane is actually faster in one direction than it is the other. So, for example, if you're flying from Toronto to Vancouver, there's something called the jet stream that goes across Canada, and the jet stream is essentially a large current of wind and weather that goes from the west to the east. So a majority of the wind is blowing in that direction. The clouds and weather goes in that direction. So when you're flying from Toronto to Vancouver, often you are flying into the wind or into the jet stream. So it actually takes longer to fly from Toronto to Vancouver than it does coming home. So when you're coming back, you're with the jet stream, and the pilots will find themselves in the jet stream and take advantage of that and help push you along. It takes less gas and everything like that as well. So these vectors are all taken into account when we're flying a plane. Okay, so now we've set up this vector diagram, and now it becomes a simple addition of vectors. This vector plus that vector gets you this red one, and we've got a triangle, and we're going to try and solve it. If I wanted this third thing, you might need this thing at the end to make it all so you can have all your reference points. All right, so what I've done is just taken this and copied it over here, tidied it up a little bit, and I've added the 500 and the 85 because that's how long that is, how long this is. I'm interested in doing that, and the two known angles. So now I have to solve this triangle. Now, in order to do this, I need a little bit more information because you'll notice that 30 degrees is not actually an angle in this triangle. It's only this little angle here. I need to know this little angle here so I can figure out the entire angle in my triangle. So the question is, how big is that? Well, I can actually look at this vector, this blue vector, and I see I've got this 40, which is outside of my triangle. But I can do the Z pattern. So I'll just trace this out for us. Here's the Z pattern. It's going to be a little messy, but we'll try our best. There we go. There's the sideways Z pattern, which means this angle here is the same as that angle there. Okay? So I'll just get rid of that messiness. All right, so there's the 40, and you can see the Z pattern. That means that this angle in here is 40 as well. Again, 40 is not an angle in my triangle. It's a part of the angle in the triangle. The angle in the triangle actually goes right across from this blue line to the blue line, but it is a combination of these two vectors, which now I can say is 70 degrees. And that is an angle in my triangle. And I now think I've got enough information to figure out this side of the triangle. This is where our sine law and cosine laws are going to come in. Here I've got two sides and the inside angle, and that means I'm going to use the cosine law. The cosine law says it's c squared equals a squared plus b squared minus 2ab cos c. How does that translate in this case? Well, the c squared is the ground velocity, so I'm actually going to call it g squared. I'm putting the absolute value bars over here because I'm only talking about the magnitude right now. Okay, so I'm only talking about how big it is. So it's how long this side is. That's why I have those absolute value bars, the magnitude squared. So it's g squared equals a squared plus b squared. In this case, the a squared is like 500 squared plus 85 squared minus 2 times 585. And then cos, the angle in between those, or opposite the g, in this case is 70 degrees. And so now it's a matter of going and plugging this into your calculator, and I'll let you do that. I'll go and do it in my calculator. I have the luxury of being able to type all of this in. 400 squared plus 85 squared minus 2 times 500 times 85 cos 70. Okay, so I have the luxury of being able to do that. If you don't have that luxury, you might need to do some of this math first and put it in your memory, and then do 500 squared plus 85 squared minus whatever you have in your memory. But I have that luxury of there. 228,000. I don't think that's how long that is, but oh yes, remember it's g squared, so I got to take the square root of this answer. The answer key is really valuable in these lessons, and I get this big long decimal. Now, the reason I'm showing you this on the calculator is because I want to stress how important the big long decimal is. So I'm coming back to that in a second, but these steps I'm going to let you figure out on your own to make sure you can work your calculator, but my calculator spits out this answer, which we would normally just round that to 477.7 kilometers as the speed, okay? But we'll come back to this big decimal in a second. So the speed is 477.7. So it is less than 500 as we predicted, okay? Because we are flying a little bit into the wind, so the wind is slowing us down. Okay, it's not 500 minus 85 because it's not flying directly into the wind. It's flying, the wind's influencing a little bit, moving it off to this side. Okay, but it is less than 500, which is great. That's not always going to be the case. It might blow with it. It might go on off to the side. It might actually increase it. Who knows? Okay, we'll find out those in a second. All right, so that's the speed, but now we need to know the direction. So we got to know where our plane's flying. We don't want to just let the wind blow us. So what we need is a direction. So we don't define direction by east first. We always go north, south, and then go east or west. So in this case, I want to go north all the way over to this guy, which means I need to figure out this little angle inside that triangle. Okay? And to do that, I'm going to use the sine law. So the sine law will be this side compared to that and compare it to a known side and angle. So there's an angle, and now I know what this side is. So I don't need to figure out this angle over here and use the 500. I can use this number. So to do that, the sine law, this is my unknown. So I'm going to start with the sine law on the top and go sine theta over its opposite side, which in this case is 85. And I need to compare it to a known side. So the known angle and side, well, the known angle is 70, and its opposite side is G. But I'm not going to use 477.7. I'm going to use this big long decimal, which is still in my calculator. Okay, so if you know how to work the answer key or the memory feature, you want that big long number. Okay, accuracy is super important. I'll talk about that in a second. Okay, so now I can solve for this. So solving for this, since it's divided by 85, I'm going to multiply it up here, and it becomes times sine 70. Okay, and this is sine theta, and it's being divided by that big long decimal again. And then we're going to go to our calculator to solve this. So again, I have that. I've got an answer key, so I'm going to save that. So I'm going to go 85 times sine 70 divided by the answer. There's my answer. And I'll get a decimal. Of course, remember that's for sine theta. So I need to push second function sign, inverse sine of my answer again to get 9.62 dot, 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 dot. Okay, and I'll get this big long decimal. Here I can round that to one decimal place and say it's 9.6 degrees. Okay, all right, so that's the importance of using this big long decimal. The reason that's important is because even with rounding to one decimal, or worse, rounding it to a completely whole and say 478, it will influence this significantly. So if I go back to my calculator and I do this and I go 85 sine 70 divided by, let's say I rounded it to 478. Okay, so you're going to see a different answer. Okay, it's 9.619. Now, you might not think, you know what, they both round to 9.6. You might not think that that's a big deal, but it's actually 1/100th of a decimal place off. Okay, and when you're flying a plane at 500 kilometers an hour, half a degree off, which is, or sorry, we're talking 1/10th of a degree off. 1/10th of a degree off might not seem like a big deal at the beginning of your trip. But if you are off by 1/10th of a degree going 500 kilometers an hour for 8 hours, that little error at the beginning begins to get bigger and bigger and bigger and bigger. And so accuracy is huge. All right. And so we're going to try and keep as many of these decimal places as possible. Just imagine being 1 degree off over 500 kilometers an hour over an 8-hour flight. The result would be you might be aiming your plane at London and you end up in Paris. Like, that's how much of a big difference is. And so we're not going to be rounding until the end. Okay, so I'm going to be very, very picky about your decimal places. All right, now let's talk about the answer. Does that mean that we're going northeast 9.6 degrees? No. This little 9.6 is actually right in there. But I need to describe the direction of G. And I'm doing it from the beginning, so I can use this crosshairs to explain. So the direction of the red vector is actually north all the way over to here, to the red vector. So it's bigger than the 40 degrees, and we can see that it's actually the 40 plus this 9.6 that we got, and we get 49.6. Okay, so our direction then is north 49.6 degrees east. And we put all these together, and we then get the velocity, which is speed and direction, is 477.7 kilometers per hour, north 49.6 degrees east. Okay, so we've got a pretty good idea of how this works. Now, there's a couple of things I want you to be very careful of in this question. Let's say, let's go back, let's go over here. So a couple of things to be careful of. your angle isn't always going to be just added on. So we found that 9.6 there and we added it on. If we had a situation where the wind was blowing in this direction, okay, some measurement, it doesn't matter. Notice that our red vector then would be going like this. And the red vector then would actually probably be bigger than 500 because the wind is slightly from behind. And we end up with a red vector that's going to be bigger than 500. And the angle is going to be a different angle. Let's say it's 7 degrees. Well, now if we're measuring this red vector, it's not going to be 40 plus 7 because that would be a vector over here. It's going to be 40 minus 7 degrees. Okay, and then you would say it's north 33 degrees east. Okay, you could get in situations like this where the wind is blowing something like this. Okay, and you're not going to know from your picture whether it's actually, maybe you've drawn the vector this big and you're not going to be able to tell if it's actually blowing north or if the red vector is going northeast, or maybe the vector was supposed to be a little bit longer like this and it's actually blowing slightly northwest. How are you going to know? Well, you're not going to know until afterwards whether you've drawn an accurate picture. So, for example, you might have predicted a picture something like this. Okay? Again, this would be a different question. Maybe your vector is bigger. It's like 120 kilometer hour wind. You might predict that this is what the vector is doing. So you do your math, you got everything, and then you go figure out this angle. And then you figure out the angle is actually 42 degrees. So at that point, if your angle is 42 degrees, it turns out your picture was a little bit inaccurate, but that's okay. It still got your math right. But if you find out that it's 42, that means the angle must have been slightly over like this. And your vector should have been something like that. And now when you describe your red vector, you're actually, if it's 42 degrees, it's actually north 2 degrees to the west. Okay, so these are situations that might happen. Okay, another situation that might happen is something like this. So remember we had it blowing like that, and we had it going like this, and we found out the red vector was smaller. Now, if I change the direction of this wind into something like this, it's actually going to make the red vector maybe bigger than 500, even though it feels like you're blown into the wind. Okay, but it's blowing it so far across that it's actually maybe helping the wind, the plane a little bit, even though it's slightly into it. And so you could compare these two vectors and find out that in fact this vector, this red vector, might actually be slightly bigger than the original. So don't just assume that it's going to be hurting the plane. In ours, it was because you were flying almost into it. Okay, but maybe it's off to the side here, and the plane is going like that, and you actually have it helping a bit. Okay, you could even have it down back like this. Now you're definitely blowing into it, and it's really hurting it, right? You can see the wind blowing. If the wind was going exactly in there, I'm just doing it so you can see it. You can see that it'd almost be a subtraction of the airspeed minus the wind. Okay, so these are all different scenarios that might pop up in your question that I want you to be aware of. Okay, so lots to talk about in that question. There are two questions out of the textbook that I want you to try now, page 22, number 6 and 7. I briefly want to talk about them because of this. In this particular question, it says the wind is from the north and there's no angle. So you see in ours, there was an angle of the wind. So this just says from the north. Well, if it's coming from the north, that means it is blowing directly south. Okay, so the vector is something like this, directly south. And so now you've got a 90-degree angle. Okay, so just be aware of that. The airspeed is north 60 degrees east, so it's going northeast, but you're going to be adding a straight down one. It'll actually make this question a little bit easier because when it's off, you have to do that math on the angle. But here, you actually be able to get that it's straight down. Okay, so just be careful of that for page 22, number 6. And I also want to talk about this one. It says the wind is from the east, so that's blowing west. but the plane is steering southwest. So where's the direction? Well, it says southwest. So what does southwest means? Southwest means it's moving exactly between south and west. So if I was drawing the vector, I'd go south and west, and southwest is exactly halfway in between, which means the angle between them is 45 degrees. Okay, so southwest means south 45 degrees west. Okay, instead of saying south 45 degrees west, because it's exactly in the middle, we say southwest is that. Okay, so that helps you with those two questions. So that's all that the only two questions you're going to do today. All of this is all about just answering these airplane questions, and that is one of our classic calculus questions. Good luck.